Right, so when we're classifying them by angles, right, so we have an acute triangle, right, which means that it has 3 acute angles. Right, we can also have right triangles, and they have 1 right angle. And we can also have obtuse triangles. And they have 1 obtuse angle. Right, and an obtuse angle is what?
Bigger than 90.
Yes, it's larger than 90. Right, so again, when we're classifying by angles, we can have acute, right, obtuse. Have equiangular. Right, and so that means all 3 angles are congruent. And so in a triangle, that means all 3 angles would have to equal what?
Equal.
90.
No.
95.
No?
They're just congruent.
No, all 3 add up to 180, so each individual one would be,
60.
yes, 60. And yes, all angles in a triangle add up to 180. I'm going to repeat that. We can also classify triangles by their sides. All right, so we have a scalene triangle. And that means that no sides are congruent. So that means all 3 sides are a different length.
Is that also a Whiteboard?
Not necessarily. If the angle's not marked with the right angle symbol, then you can't call it a right. I'm just worried about the sides right now. All right, we also have isosceles. And that is where 2 sides are congruent. Somebody sneeze?
Mm-hmm.
Oh, bless you.
That's nice news.
Well, bless you. You're welcome. All right, and then we also have equilateral. Did you just say saucily?
Yeah, I thought it was like one saucily.
That is kind of what it looked like. Now it's going to bug me that that's really far away. There. That's better. You're welcome. Right, and so equilateral is when all 3 sides are congruent. I know, they're really hard to draw. But the key thing with these is, like, as long as the sides aren't marked. So, like, see these little lines here? That means that those two sides are congruent. Like, since they both have two lines, that means any of the ones with two lines are congruent to each other. Same thing here. Since they're marked congruent, you can assume they're congruent. If they're not marked, then they're not congruent, even if it, like, looks like it. But you've got to pay attention to the markings. Same thing with angles. Like, the angles have to be, like, marked with the little, like, curvy things that they're congruent to be congruent. So you've really got to pay attention to that. Okay, so I do want to talk through some theorems, which you can write on your sheet. We're not going to do proofs with this chapter, but there are some things that I just want you to go ahead and write on your theorem postulate sheet because you can still use that on tests and quizzes and stuff.
Were we supposed to write the theorems from the last chapter?
Do we have to?
I think you guys wrote them one day. There we go. So these all need to go on your theorem and postulate sheet. So the first one, they're also in your book on page 149 if you want to copy them from there. I'm putting them in this mostly for people that are not here. So again, the first one is the sum of the measures of the angles in a triangle is 180 degrees, right? So the three angles in a triangle will always add up to 180. And then we've got corollaries, which are just like other things that we can assume because of some of these theorems that we know. It's not technically a theorem itself, but it's just another thing that we know and can assume to be true. So that one says the acute angles of a right triangle are complementary. What does complementary mean? They add up to 90, right? So that makes sense. If you have a right triangle, that means one of the angles is already how many degrees? 90, right? So if all three add up to 180, that means the other two, if one of them's already 90, the other two have to add up to 90 because 90 plus 90 is 180. So like these two angles here are going to be complementary, which means they're going to add up to 90. And we kind of already talked about the second one on there, that each angle in an equiangular triangle has a measure of 60 degrees. Right, so if all three angles are the same and all three angles have to add up to 180, you just do 180 divided by 3 to get 60. For this last theorem, so it says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So what that means is if we have two triangles, so we have two triangles. So let's call them triangle ABC and X, Y, and XYZ. So basically, if we know that angle A is congruent to angle X, and we know that angle Y is congruent to angle B, that means that angles C and Z would also have to be congruent to each other. So basically, if you know that two angles are congruent, the third one also has to be. So that tells us that this is congruent to this. So again, if any two angles in a triangle are congruent to two angles in another triangle, then the third angles also have to be congruent. Oh, sorry. technically. So it forms a linear pair with one of the angles in the triangle. Huh? It would be angle 4. Yeah, so in this case, it would be angle 4 because it's on the outside of the triangle. Right, but it's just right up against it. And with that, we also have what are called the remote interior angles. And then these are the two angles that are not adjacent to the exterior angle. Yep.
Wait. Okay, so yes.
Right, so in this case, it would be 1 and 2 because they are not touching angle 4. Right, so we could technically, like, draw an exterior angle from any point in this triangle, right? So, like, if my exterior angle was down here, then, like, well, if I extended this out and said this was, like, angle 5. So, if
More than one.
yeah. So, if we're talking about angle 5 as the exterior angle, then the remote interior would then be 1 and 3. So it's going to be whatever two angles aren't touching the exterior one that we're talking about. Does that make sense?
Yeah, but how do you know which one you're talking about?
It would tell you in the problem.
Okay.
Like, yeah, it would. You'll know. I promise. So there is also a theorem that goes along with this, which is the exterior angle theorem. And instead of taking a picture, I'm just going to go ahead and write it. The measure of an exterior angle of a triangle is equal to the sum of the measures of its two remote interior angles. So if this is our triangle, so let's say we've got 1, 2, 3, 4. That means angle 1, so like the measure of angle 1 plus the measure of angle 2 would be equal to the measure of angle 4. So the remote interior angles add up to the exterior angle.
Oh.
Which makes sense though, right?
Yeah.
Because this is a linear pair which adds up to 180. And inside the triangle has to add up to 180. And so if we already have this angle, then that means these two would have to add up to the same thing this does. So it's kind of cool how it all like comes together. All right, so that's it for notes today. You do have a homework assignment. Way to sound so excited, guys. The legs would be like the two congruent sides.
Okay, and the base and the base.
Yeah, the base is the other side.
Does the base have to be
It doesn't have to be on the
on
bottom.
the bottom?
No. For 10, when you have a right triangle, the hypotenuse is the side that's like across from the right angle. And then the sides that like touch the right angle or form it are the legs.
Legs form it?
Yeah, so like you've got the two legs that make the right angle, and then the side across from it is the hypotenuse.